Hello, everybody. Welcome to anybody who watch this video. Our third session when we are talking about ANTLR, creating your own DSL using Golang. For those who just joined or just found this channel, welcome. Here we are talking about any IT issues, IT architecture. Maybe you can watch coding with me. Could watch me coding as I explain everything along during the coding. We are talking gossips about IT, anything. For those who already found and watched my previous video, welcome. Welcome back to Benak Arsitek. We're going to continue our last session about programming Simon. Yeah. If you don't know what Simon is, you can watch my previous video, my last three, in fact, 2 or 3, about what is Simon and how I do things with regard coding the Simon. It's a Golang programming. We develop it using Golang programming language. There we utilize a couple of library, like right now that we are using ANTLR to generate our parser, because when you follow my previous video, you can see that we need to have an expression parser because we need to put our own DSL into the solution. Yeah, so continuing from our last session, yesterday we are creating all of this AST node. AST is sort of abstract syntax tree. All of this node we create is just according to the grammar that we specify in the G4 file. This is the ANTLR grammar file. If there is a parser for expression, then we create an expression structure. If we have constant, then we have a constant structure. So on and so forth. Expression should contain constant or function or an expression, left side expression, operator, and right side expression. Left, right, so very simple. So we can see that the expression should have a constant or a function or these three. If there is a constant, means the constant is not nil, and the other should be nil. If the function is not nil, then the constant and the other is nil. So on and so forth. If there is a left expression, then the left expression, the right expression, and the operator should not be nil, while the other is nil. It's quite straightforward. So, and then for each of this, we create an evaluate method. For example, expression have an evaluate method. When the expression get evaluate, first we check if the constant is not nil, then we just return the constant evaluate. If there is a function is not nil, then we just return the function evaluate. If we have left, right, and operator is not nil, then we do the evaluate. It's very simple. We just take the operator. If the operator is a plus, then we take the left and the right, and then we do the operation. So we compare. If the left is string, the right is string, then this is what we're going to do. We do concatenations. If the left side is string, the right side is an integer, this is what we do. We concatenate the string with the integer, so on and so forth. We do this for all possible activity that may happen to an expression. So because the expression could, if the expression is a constant, then we are done. If the expression is a function, we are done. But if the expression have left and right expression with an operator, then we have to do everything. For our operator plus, when we have this a string for the left side and then string for the right side, we do for all the plus thing. If the left side is an integer and then the right side is a string, what we're going to do. All of this is explained. By the way, if you want to follow this project is actually published. It's a public repository in my GitHub. Let's see. GitHub. Simon Agent. Yeah. This is a repository that you can always pull or clone or fork if you wish to learn. Every time I've done with something, I always push to this repository. So you can see the code live here. You can take a look into the G4 file, how it get implemented and everything. So you can always go here. Sorry, but is this project is a public project? Hold on, I hope it's a public project. Sorry. Yeah, it's public. There is no signature like private. So you are welcome to clone or to fork or just to download the source code and then evaluate all the codes within for your learning journey. Okay, let's continue. Yeah, so with all of this, we can make sure that the expression always works, and it will throw error when it cannot do some calculation or whatever. So I also created some tests. So we can test if there is a left side is an integer and the right side is an integer and the operator is plus, then there should be no error and the result should be something like that. Left side is integer, something like that. This is for all plus. I need to do more tests for minus, for multiplication, subtraction, multiplication, division, modulations, logical AND, logical OR, equals, not equals, less than or equals, greater than equals. So just simply doing something like you just add it like this. It's a minus operation. For example, if we want to minus 1 to 3 minus to 3, then it should be 100. Something like that. So if both integer 64, then the result should be integer 64. I need to do this for minus, for logical operator, for anything. But like all lazy developer I will do this a little bit later. Yeah, I will do this a little bit later, no problem. Okay, what we're going to do next? Now we're going to implement the function literal, the function AST node. So a function should have also the same like evaluate. So function will have name and also list of arguments, right? So how we can do this? Okay. First, we need to know what function. Let's define some functions. For example, a function to uppercase a string. Okay. If the function name, better using f. Okay, f dot name equals to upper. If the function is upper, then we expect that the argument should not be nil. If function dot argument is nil, we return an error. To upper function requires an argument. Okay. To upper function will normally require one argument, right? It's logical. To upper is to uppercase all the letter within a string, and then we return the string as the string. So we're going to check the argument. Function dot arguments dot argument list dot first, maybe I'm jumping too far. We should start with argument. How we can parse an argument list. Okay, argument have arguments, and then we should evaluate the argument just like a function. Before you run the function, all the argument inside we're going to evaluate. Okay, argument. But this time the evaluate will return array of interface, because when we have a function like this, argument 1, argument 2, means that the argument list contains an array of interface, an array of values. So this evaluate specifically for argument list will return an array of interface, right? And then we do something like arguments equals to make, we create an array of interface. Array of interface. Okay, and then for each of the arguments, for index value range of function arguments, okay, the arguments at e equals to the v expression, because this is an expression, right? Array of expression value dot evaluate. Oh, I'm sorry. Okay. We append. My mistake. Okay, evaluate. Oh, evaluate have error. actual error. Okay, if error is not nil, we just return a nil with a return a nil with the error. Function this argument error with the error message. Okay, so the function name, we don't have reference to the function name, so we just say that argument means the index got an error like that. We just simply return it. So if there is no error, then we append into the argument containing the actual value. Okay, because this evaluate is an integer, is a interface. Okay, and then we return the argument with no error. Okay, back to the function. The argument, let's evaluate the argument. So argument values equals to function arguments evaluate. Okay, there is an error also. Okay, then if there's an error, okay, we return empty dot error f function this name got this error. This is the function name and this is the error. Okay, return it. Yeah. Okay, if there is no error, then we check to upper. If the function is to upper, we expect that the argument value should be at least one argument value. We expect the argument value is not nil, and the length of argument value is equals to 1. There is one argument. Okay. If argument value is not nil. Okay. Else return error. Nil and an error. Function this requires one argument, which is this is the function name. Okay, and then here, if to upper argument value is not nil and argument value equals 1, we make sure that the argument value, the first value, is a string, right? So argument values, the first argument, right, we make sure that this must be a string. So using reflect value of argument value, the first argument value, dot kind. So put if kind is not equals to reflect dot string is not equal to string, then we just return there is an error. Oh, let's make is equal to string first, otherwise we throw another error. Function requires string argument. Okay, we return strings to upper the argument value, which is a string. With no error. So I hope you get the logic. So if the function name is toUpper, we check that the argument value should not be nil and the argument value is should be 1. If there is its argument value is nil or not 1, then it will return, it requires 1 argument, an error. If the argument is in fact 1, and then we check that that argument, the first argument, is the kind is string, we can get that value as string, this integer, because this is actually an interface. So we must cast the interface back to string, and then we uppercase the string we return as the result of the function. So we only have one function so far, so we can create toUpper, toLower, so on and so forth. Or we could use the elegant way, switch function dot name case toUpper, right? So this is our first function, toUpper. And default, just return function is not implemented. Okay, so we have a function called toUpper. And then we have a function called toLower, obviously. Just do it. We require 1 argument. Okay. Or let's implement something with 2 arguments. Function, for example, case, the function name is left. Left if means like the left is like something like left some string abc 1, it will return a. It will take 1 character from this string, from the left, from the right, something like that. So left. So it requires 2 arguments. So function left requires 2 arguments. It requires string and integer argument. So we say that this is 0 means that the first argument should be a string, and then the second argument should be integer. Integer 64. Okay, then we can do something. We get the first argument as string, and then simply do that. We need the left, so it's starting from 0 until the index, which is argument 1. Right, argument 1. Like that. But how about if the string itself, the length of the string is not enough? We cut from left 3 characters where the string itself is only 2. Or if the second argument is minus, is negative, we have to take that into account. If the second argument, integer 64, is less than 0, is negative, then we just return an error. Function name, second argument must be positive. Found that, sorry, the length, this we just written this, so the error will be more informative. So if the second argument is less than 0, then it will return an error. If the length of the string length is less than the second argument, you also return an error. We cannot compare integer and integer 64. Bugger. So let's cast it into integer. Then we just return function length first string argument is shorter than the offset, than the specified offset. Just put like that. Okay. Or we could put other behavior. So if you want to do something like this, the function is left, and then the string is ABC, meaning on the length only 3 characters, and then we want to cut from the left 5 characters. So we just return ABC. Logical, because there is no more characters, because yeah, the caller should not expect that the return will always 6 characters, because whatever variable here could be less than 6 characters. So if it's like been less than 6 characters, mean the string is shorter than the offset to cut. So with this, we just simply return the argument, the string argument. With no nil. It's logical, right? Yeah. Cutting left, cutting right. Of course, we're going to need string length, for example. str string length. Or simply, yeah, length. So with length, we only need one argument. Just better copy from that one. Yeah. So if it's length, then the argument should be at least 1. Okay, and it return the length using len. Yeah. We always make sure, oh yeah, before I forgot, we always make sure that the return should be in the 64-bit variant. So we cannot do other than that. Otherwise, it will create unpredicted results. So this one return a string. This one return a string, no problem. This one also return a string. Now this one, the length, we want to check the length of a string, then it will need one argument. Okay, and then the length, this length is returning an integer, not an integer 64. We need to convert that into integer 64. So integer 64. Yeah. That's how we're going to do that. And so on and so forth. So we have at least 4 function. To upper, to lower, left. We also need right. Do we? Later. This is just an example of how to create a function in our DSL. Okay. Now we have our functions done. We have our expression done. We have our constant done. All the literal is done. Argument list also done. Float literal function, integer literal, yeah. Operator, we don't need to do anything with the operator. String literal. So actually we're done. Now let's construct our AST using the parser. This is very important part, guys. So you should pay attention on how we're going to do this with our listener. So first, when you look into this graph, okay, when you look into this graph, for example, 1, 2, 3 plus 1, 2, 3. something like that. When you look into this graph, you have an object called expression. Yeah, we have our expression structure. It will have expression on the left and expression on the right. Inside the expression, you have a constant. You have an integer literal. So when you construct this tree, you have to work with stack. So first, when we parse the expression, we have the first expression node on the stack, which is on the bottom, and then when we parse the expression inside the left expression, you need to create another expression on top the first stack, and then when you create a constant, you have to create another AST node, which is constant above the expression, and so on and so forth. When we're done, we need to remove the stack again, so we can go back to the bottom, to the first expression here. And when we make an operator, we're going to create another object above the expression. When the operator is done, we need to remove the operator. Then we go back again to the first expression, and so on and so forth. So we are working always with stack. Thus, we need to create an implementation of stack. Actually, there is a lot of implementation of stack in the internet, in GitLab for Golang, but I'm going to create a very, very simple implementation of stack just for the purpose of parsing. Let me see my cheat sheet again. A stack. Where is my stack? Oh, sorry. Okay. Let's create a stack. Yeah. So you can look into the source code later on about the implementation of the stack. So stack is actually will have a function to put an object on top the current stack. We need to push, and then the pop will take the topmost object of the stack and then remove it. The pick will take the topmost object but not removed. So we able to pick what is actually the topmost element of in our stack. So len will inspect the length of the current stack. Yeah. So there you go. We have a stack. Okay. So let's do it. Our parser, okay, will have a stack. Simple. And then our parser also actually, I want to talk about the rootmost object, the first object that we put into the stack. But since let's not confuse us with the initial object put into the stack. Let the parser do it by itself. The moment, let's do it like this. Enter expression. The moment we put, okay, how can I explain this? The moment the parser see an expression, it will call start expression. Okay. This is an expression. You see, the rootmost object is an expression. So start expression will be called first. So we have this start expression. Where is start expression? This is exit expression. Start expression. Where is start expression? This is all exit. Enter, sorry, enter expression. My mistake. Enter expression. So enter, exit, enter, exit. It will call enter expression. So what we're going to do, we're going to create an expression object. Expression equals to a new expression object. This expression. So what is not appearing? Why? Because we are not saying that this is a Simon Lang. No. No. An AST. Yeah, it should be an AST, right? Yeah. AST is already there. Okay. It's found. Error is because the expression is not used. So, and then this expression we push into the stack. So S stack push expression. We simply do that. Okay. When we exit from an expression, what we can do, what we should do. So assuming that we're doing this graph, okay, when we are assuming this graph, exit, we can have enter expression here, we can have enter expression here. Okay. What happens if we're done with this expression? So the exit expression is called, meaning that this enter expression, this expression need to be added into the parent expression. Right, because we're going to take it out from our stack and put it into the underneath expression. Okay, expression can only be owned by another expression. You can see that this expression will have a child expression. This expression, the parent is that expression. There is no other expression owned by any other node. Argument lists have expression. Oh, I'm sorry. So yeah, there is two possibilities. There could be argument list as the parent, and there could be an expression. For example, function sorry, it must be literal, like that. So this expression have a function. So, and this function will have argument list. Argument list will have another expression. So expression is owned by an argument list. This function is owned by an expression. So there could be an expression exit here, and there is an expression exit here. Well, while the parent of this expression is an argument list, while the parent of this argument expression is none, because there is no expression above it. So first, let's see if the expression is having no more parent. So let's see how we're going to parse this. When we call exit expression, we're going to pop the expression from the stack first. So stack expression stack pop. So s.stack.pop. Right? What we pop should be an expression because this is exit expression. So we just easily parse this into an expression. Okay, and then we put it into an expression. Okay, while the parent, let's see, if the expression is the topmost expression, meaning that this is the first expression that we see inside our stack, I keep going back and forth on this ANTLR preview like that. Because the topmost is always an expression. Expression is always the first element that get into the stack. So we must check if the expression have no more parent. How can we look? We need to make sure that first, let's check after we pop, we make sure that the stack is empty. If the stack length equals 0, okay, if the stack is equals 0, meaning that this is the topmost stack that we have here, the topmost expression, we simply put the expression into the listener. Root is an expression. Okay, then we put the root. Root is equals to expression. Okay, else if the stack is not 0, means there is a parent. If there is a parent, there is two possibilities, because stack can be owned by another expression, can be owned by another expression, or an expression can be owned by argument list. So if else, we need to check if the parent is expression. How we can see the parent? We just pick into the layer of the stack. So if s.stack.pick, we would not, we don't want to take out the parent from the stack. Pick, meaning that this is the parent. The parent will be in the interface, If the parent is equals to how can we check? Reflect dot value of parent dot type dot string equals to, right? If pointer to ast dot expression, if the parent is an expression, then we cast the parent into an expression. We cast it into expression. And then we just set child expression of that expression. I hope it's not too complicated, because expression have left expression and right expression. So we just create function for this expression. Accept child expression. We accept an expression. Okay. And then we put, if the expression left expression is nil, then we put e.left expression equals to the expression. Okay. Else, if the left expression already set, we put it at the right expression. So we can call this in our listener parent accept this expression. I hope you guys understand the logic here. If reflect value of, sorry, let's copy this. If the parent is an argument list, then we do the same. But this is for argument list. So argument list need also have the same method as the expression. Let's see the expression. Copy this, put it into an argument list, make this an argument list. Okay, we just put the expression into the argument there. So simply argument list dot arguments equals to append from the argument list with the new expression. We just simply add arguments. Okay, when we are done with that, then there is no error. Okay, to make it nicer or elegant, we just use else and else, because if it's not, I mean, this is an error, something is wrong. So what we're going to do, we're going to log it out. Log fatal parent is not an expression nor argument list. It's a something like that. We have fatal, okay, with like that. So we know when if we address the casting wrongly, then we know what to do it proper, how to do it properly. So exit expression. Okay, at the same time, let's do a test with our parsing. Where is our test? Let's test our parsing function. Test test parse test. Okay. Again, I will look into my cheat sheet. Hold on. There you are. Test parser. Yeah, this is how we're going to test our parser. Okay, the data is already in string. For example, we have a string data equals to 1, 2, 3 plus 5, 6, 7, 8. There is no more error. Just remove that and then make it nicer. Okay, the input stream is the data. The parser is new. The new, we use Simon Lang. New Simon Lang parser. Okay, and then using a default tokenizer. And then we don't need this. Yeah. Yeah, we need to create our own what is it, listener here. You don't have a function to create one. So simply we just create new function, new Simon agent listener. We return a Simon agent listener, just like that. Return Simon agent listener. Okay. So the stack will be a new stack. Yeah. Stack is a new stack. You don't need this actually. So new Simon agent listener without any parameters. We get our listener and then create a parser, which is a Simon lang, new, like that. Change this into parser. And then we walk. See whether there is an error. Parse error. Parser's error. Actually, this parse error need to be set when we walk the listener. But this is later. Later we're going to implement this. For now, we don't need this because we need to capture the parsing error. If we have a parsing error. Okay. Let's test that. Though import and not use IOUtil. Go away. What is this? Oh. This is actually the data. Right? The data, right? Oh yeah, PSR, not GRL, but expression. The parent, the topmost node that we're going to use the parsing for. Let's see how it works. Yeah, no problem. So if you want to see how it is actually, how the worker actually iterate through the parser, let's do some short old school debugging. Old school debugging. Let's put, where is my listener? There you are. There is no fatal error. Let's print out. Enter expression, exit expression. Enter expression. Okay. Enter function. Exit function. Enter constant. Exit constant. Enter operator. Okay, let's put it like that first. Let's see what happened when we run. See, enter expression, constant, and then it enter expression, and then enter a constant, exit a constant, exit an expression, enter operator. So let's look, because what we are parsing here is an expression, something like this. So let's copy this and then try to look how it looked like. So we just copy that, put in, I don't know, Sublime maybe. See, and then let's look into the expression. What we're going to put? 1, 2, 3, 4 plus 5, 6, 7, 8. Let's compare this. This is the sequence will be called by ANTLR. Enter expression means that enter the first expression, and then call enter expression meaning that it enter this expression, and then enter constant, and then enter exit constant, because once it's done with the constant, it move back to expression. So exit expression, because in integer literal we don't put a debugging message there. So and then exit expression, this expression, and then enter operator. They enter the operator here. Enter operator, exit operator, enter expression, this expression. So it's going like that, and then going up, and then going down, going up again, going down, going up, and then it finally exit the last expression. See, exit expression, this expression should be that expression, and this expression should be that expression. So I hope you understand how the ANTLR parser going through the expression and going through the constant, everything, how it will iterate through the AST, the abstract syntax tree. So our listener, when it enter an expression, it will create an expression object and put it into stack. Okay, and then when it's exit the expression, what it will do, it will make sure that there is no more parent. If the expression is at the topmost, then we just save it as our root. And then if the parent is not nil, then we need to know what is the parent. If the parent is an expression, then we call the expression to accept this new expression that we just popped as the child expression. If it's an argument list, then accept it as an argument list. So we can also do it like, you can easily test. For example, we have a function where the function take an argument, which is inside the argument is actually an addition. Let's run our test. See, so it will know. Let's look again. If we have a function, so it will go to expression and then function and then argument list. We haven't put that. You won't see it. Do we? Where is our enter function? We print out constant, operator, argument list we don't put. This is just to demonstrate to you how the parsing actually working. Enter argument list. Exit argument list. Right, if you try to run this, Where is the test? Yeah. Okay, you can compare it with that. First is enter an expression, and then function, and then argument list. This is they don't parse because this is already a fragment. And then after the argument list, it enter an expression, and then enter another expression. After that, going to the constant. Okay, after constant, we go to the integer literal because we don't print out the integer literal. It immediately exit the constant, exit expression. Okay, and then enter operator, so on and so forth, and then exit. So I hope you get the idea. Okay, now we continue. We don't see any fatal, right? We don't see any fatal. Okay, then what next? Exist, now enter function. When we enter a function, we just simply create the function. Equals to a new function. Right? Function would have what is it? A name and an argument. Okay. How we can set that? We cannot access anything because it's private. Let's refactor this one. Rename into name. This rename into argument. So our listener can access directly to the function. So the name is equals to the context dot function name text. So we can, and you can see the inside the grammar. So a function would have a function name. It will have also a b open, a brace open, an argument list, and also a brace close. When they parse function, there will be a callback. There will be a callback called function name and an argument argument name and function name and argument list. How to get the function name? Simple. From the context, we can get the function name from there. So enter function. We can just call the context, and there will be a function name function. This already been prepared by ANTLR. And inside the function name, we just get the text. So you get the name. Okay. And then what we're going to do, we just push the function into the stack. Simple. Okay. And then when we exit the function, we're going to pop the function out from our stack. Function is from the stack, you pop, and it should be a function. a pointer to a function I asked. Right? And then this function needs to be added into the parent. Let's see who owns a function. Function is owned by an expression. Who else? It seems function only owned by expression. So there is no other owners of function. So we just simply take the parent as an expression. Okay, parent is stack peak. Sorry, peak. And it must be an expression. That cannot be others. And then from this parent, we're going to add accept function. Put function. Okay. Then in the parent, which is in the expression, we're going to implement accept function. Like that. This is, of course, a function. Okay, we just put expression dot function equals function. Okay, done with function. Now with constant. Like we always do, if we find a constant, we create the constant object and push it into the stack. So there will be a constant. And then from the constant, we push the constant into the stack. Okay, just like what we always do, we repeat this again. If there is an exit constant, meaning that the topmost must be a constant, and then we need to put this constant into the parent. Who owns a constant? Let's look. This is constant. Who owns a constant? Only expression have constant. So we sure that the parent will be an expression. So yeah, we get the constant from the top, and then we pick the parent. It must be an expression. Then we call parent accept constant. Then we just pass in our constant. Okay, so we need to look into the expression. The expression must accept constant. Okay. E dot constant is constant. Done. Okay. Parent constant accept constant. We are done with a constant. Then we do operator. What we do when we enter an operator, we can simply that the operator is always easy. Operator is only contains strings, like we already explained. Operator is only, this is the possibilities of an operator: a string of plus, a string of minus, and so on and so forth. But an operator only owned by, who else owns the operator? Only an expression. Since operator only owned by an expression, like you already know, this is the operator owned by the expression, right? We just accept function, accept operator. Okay. Just simply put the operator there. Okay. In our listener, when we enter an operator, you already know we're going to push the operator. Oh, what I do? Okay. Just push operator. Oh, this is bad naming. Okay, we push constant there. Push the operator. The operator can only have string, right? So because this is we enter operator, so the context should be the operator string. Operator. How can we access the operator value? Operator is okay like that. Wish better not do it like that. Refactor, rename operator. So we can access the operator string. Here, operator dot operator equals to the context dot text. Okay, and then we push the operator. When we exit the operator, we know that the operator is owned by an expression, so we just copy like that. Okay, so it is an operator. Parent is an operator type, and then we simply call parent accept accept operator. Okay, argument list. When we have an argument list, we just create the argument list like usual. Okay. Argument list will contain argument, which is an array of expression, but this could be problematic if we want to try to append something into this argument. Okay, if the argument is nil. So we have to make sure that this argument is not nil. If arguments is nil, we simply return empty argument, right? Yeah, when we want to accept an argument, yeah, we need to create the argument first. We have to create the slice, otherwise we get an exception, panic. Okay, so and then yeah, we create our argument list object and then push it to the stack. Okay. When we finish with an argument list, this argument list will be put into the parent. The parent will be, let's see, who is the owner of argument list? This argument list. Find. Okay. Argument list belong to a function. So the parent must be a function, cannot be others. So we look into the function here. So there is an argument list. Oh, the function have a public argument, so we just use it straight away. When we exit an argument list, okay, there will be an argument list here. Okay. And then the parent should be a function. So we can easily say the function dot argument list equals to argument list. Done. Now string literal. Like we always do. So we have a string literal. Okay. And then push the string literal into the stack. String literal, when you can see string literal, how is string literal look like? Okay, string literal. String literal is a stringlet. Stringlet is a double quote, something, a sequence of character begin with a double quote and then ended with a double quote. So the string literal itself will include the double quote. We need to remove the double quote. Okay. So what we're going to do in our listener, we're going to take from the context dot get text. This get text is a string, which is the string literal itself, but it will begins with a quote and ended with a quote. So we need to trim out the quote. So how we can do that? String value, we need to remove from here, begin from the first character, not from 0, because the first character it will be the double quote, until the length of string value, length of the text itself minus 1. Oh, like that. So we have the string value, put it inside our string literal. String value is like that. Value. Let's make it simple. Let's make this public. Where is refactor? Rename value. Yeah, refactor. Okay. So from our listener, can put value with our string value. Then when we exit string literal, we can see who owned the string literal. Okay, this string literal, copy, find. Yeah, only owned by constant. Constant own integer literal, float literal, and boolean literal. So let's do that at once. Constant. There you go, constant. Function accept string literal. It's a string literal. So we put like that. C dot str equals to L. Let's repeat that. Accept integer literal. Oish. And then float literal. And then Boolean literal. Yeah. So we just put the respective sorry, integer. Boolean is there, float is there. So yeah, that's all we need to do from our listener. When we exit string literal, let's copy this. The one we popped, it must be a string literal, and it must the parent will be the constant. So we just call parent dot accept string literal like that. So the same for the integer literal when we enter. So we need to what is actually the integer literal? So integer literal is a minus with an integer literal. So the text itself will include a minus sign. There is no code, so we can easily take the text and then parse it into an integer, base 10 integer. So what we're going to do, so we simply do string conversion, alphabet to integer of the context, get text. Okay. Here we will have an error. Okay. If there's an error, we logged let's put an error. No? Fatal. Let's put fatal. Which is most unlikely because the parser itself already ensured that this text will be an integer, because this is an integer literal. There is no possible way that the integer literal is not an integer, right? So it is most likely that this fatal error message will not come out. So string is not an integer literal. Let's put it the string, the context text. Okay. So not the string value, the integer. So we put new integer literal with the value is integer value. Yeah, integer literal, we need to make the attribute to be visible. Make it public. Integer literal. Boolean literal. Let's make it public also. Okay. Float literal. Let's make it public. Float literal, string literal. integer literal. Okay, all of them is already public. So let's continue. So the value will be the integer value here. Okay, integer value, they need an integer 64. Okay, excellent. And then push the literal. When it's exit, we know that these literals only belong to a constant. So we pop an integer literal. We cast it into integer literal. The parent will be constant, then accept integer literal. There you go. Okay, 4 function left. We're going to finish this. And then enter float literal, like we always do that. So we need to parse this as floating point. So parse float. Okay, we need to parse the text with a 64-bit version. Okay, it will return a float and an error. Okay, just remove this. If there is an error, means string is not a float literal. Okay, and then we push the float literal with float value. Done. Then when we exit the float literal, okay, we pop the float literal. Then we put it accept float. Accept float literal. Last, Boolean literal. So parse Boolean. Okay, parse Boolean, and then we get the text. There is a Boolean value. Okay, if there is an error, this is not a Boolean literal. And then create the Boolean literal, put the Boolean value into the literal, push, and then pop it when we exit. So okay, this is a Boolean literal. Then parent accept Boolean. There you go. We already implement our parser. With minus, there is no error detection yet. So you always assume that it's always work, meaning that the syntax people put inside is always valid. Okay. Let's see how it works. Let's test this. Okay. Function test expression test t testing dot t. Okay. Okay, the data is, let's do it like that. The data is, for example, 1 2 3 4 plus 4. Okay, and then what we do, we parse We have our assignment agent listener with the listener, and then we walk. After we walk, the listener should have the root with this, which is an expression. This is an expression, root expression. Okay, this is the moment of truth. Let's see how's the root is working. So the root expression dot evaluate, it will return a value, interface, and an error. We don't like error, so we must make sure that there is no error. If there is an error, then it's fail. So if error is not nil, we simply t.error, we put the error message inside. So if there is no error, we validate is an integer plus integer, so we expect that this interface is actually belong to an integer. So let's see. Reflect value of interface, okay, dot kind equals to reflect integer 64. If not, then we put another error. Not an integer 64. Oh, 64. Then we look into the value. If interface casted into integer 64 is not equals to, what is it, 555, 5. Incorrect result. Let's see how it works. Let's run. Okay. Why? Okay, run. Woohoo! There is no error, meaning that everything is valid. Don't believe? Let's increase this by 2. Fail. Right? Incorrect result. So this mathematical operation is actually working. Let's do something like minus 1111. Oh. Incorrect result because we are expecting 4444, right? Yeah. Success. Pass. So we can do mathematical operation and so on and so forth. What else we need to do? Let's remove these ugly messages. Yeah, all of this, because you guys already get it, I hope, on how each of these function getting called by ANTLR. Do we still have? Yeah. Good. So let's test our function. We have function, in our function we have implementation of two upper. Let's do that. Okay, let's do that. Let's do that. This is our first test. Let's create another test. Let's call it test function expression. Okay, what we're going to do, we're going to call to upper a string. Okay, all is in lowercase. This is a string, right? So this is a string. We call to upper. I hope the return will be all of this will be in uppercase. Okay, so yeah, we call the evaluate function here. There should be no error, and the return should be a string, and the value should be in all uppercase. This is a string. Right. Let's try this one. Pass. So it will evaluate whatever inside this. How if we add with number? So we expect this to be, this is a string, because the plus operator is a concatenation. When we have the string and an integer with a plus, meaning that the string will be appended with the string representation of 1, 2, 3, 4. So let's try it. Voila, no error. Okay, let's record our achievement. Git add, git commit. Make the expression parsing works. Okay, git push. Okay, we have it. So before we stop here, because it's already 1 hour 43 minutes, it is a good time for me to cut this stream right here. What we learned so far, yesterday we create all of our AST node, abstract syntax tree node. So all of this node will represent all the parsed element in our grammar. And today we finish our listener. This listener will be called by ANTLR as the ANTLR itself walk into the string that it tried to parse. So when we give here in the test, when we give a string, a data to parse, wow, this is strange. We don't need that. It's silly. So yeah, when we give a data into the parser, into the lexer, see, you can see that this data is an input stream, and then this input stream we pass it into the lexer. What the lexer will do, it will try to cut down all the string into token. Once it get list of token, it will feed all of those tokens into the parser. See, this lexer will tokenize the stream into a stream, and then this stream will be fed into the parser. Then this parser will walk by calling all the function inside our listener. Okay, here is the sample of Lexa. When we run this, you can see that the Lexa will cut this text into series of tokens. Foobar, brace opened, a literal, comma, another literal, comma, function name, open brace, all of this is token. They will feed these token into the parser. And then the parser will try to identify what's the pattern. Oh, this is a pattern of function. This is a pattern of string literal. This is a pattern. And then when they found that, oh, this is a pattern of string, it will call the string literal. When it's done parsing the string, it will call exit string. When it's when it detects a pattern of function, it will call create function. So on and so forth. So there you go. This is our listener. Later, we're going to equip this listener with an error handling. Okay, with an error handling. And we're going to finalize how we can construct our context for our monitor. But we're going to do this tomorrow. Thank you very much, everybody, for following me during my programming. Actually, I'm looking for questions, but seems there is none. So I assume you guys understand. So yeah, put it in the comment if you have any question. I can always I will look into it and then try to answer your question the best to my capability. Thank you very much. See you again tomorrow in my next stream, talking about Golang, IT gossip, everything, architecture. Thank you very much. Bye bye.